ratios. Well, anytime when we're trying to evaluate sec, cosec, or cotangent, I'm not going to remember the formula for those ones. I will use the sine, cosine, and tangent formulas to evaluate. So, for example, sine. In this case, sine will be a over c in this triangle on the right hand side, and cosine x will be b over c, and tangent x will be a over b. Then cosec, you think about that's 1 over sine, and that's c over a, and that's 1 over cosine, that's c over b, and cot will be 1 over 10, and that will be b over a. Okay, so the complementary properties. All right, these ones. Let's not talk about these ones. Let's think about first. What's the other two like you learn in method? Do you remember there's two involved, pi over 2 and 3 pi over 2 for sine, cosine? What are those ones? Give you a hint like sine pi over 2 minus x is what? Cos x. Okay. I think I would recommend you remember these ones rather than those ones I list for you. I won't ask you to memorize those ones. I'll say put that somewhere on your bond reference, and when you need it, you can just look at it. I will teach you a way to think about it by using sine, cosine. What's cos pi over 2 minus x? No, just sine x. And what's sine 3 pi over 2 minus x? That's fine. Is that negative or positive? Yeah, correct. So is it's negative. Because think about where 3 pi over 2 is here, right? 3 pi over 2 is here. And then you're going backwards by x. So say here is x. And so what's the reference angle? The reference angle is pi over 2 minus x. Right? And then what you have here is this side equals to sine, negative sine of this one. Because that's the left hand side. Think about that. You change the actual angle into reference angle, and then think about the quadrant. It's in the sine. This is the tangent quadrant. Your sine is negative. So it's negative of that, and then that's negative cos of x. So it's negative. I'm just showing you why it's negative. Because it's in the third quadrant, so that's why it must be negative. The other one, sine pi over 2 plus x. What's that? Think about where is pi over 2 plus x. Quadrant 2, so it's the sine quadrant, positive. So that's cos x. And how about cos pi over 2 plus x? Negative sine x, correct. Okay, these ones are the ones I want you to remember or know how to do it. Actually, everything is related to this one. Everything is related to those two. Okay, if you can change your reference angle, everything will relate to those two. So we'll just show you one example. Let's say for the first one, cot pi over 2 minus x. Well, that is equal to 1 over what? 1 over tangent pi over 2 minus x, right? And tangent pi over 2 is sine over cos. So 1 over that will be cos over sine. And then what's cos pi over 2 minus x? That's a sine x. What's a sine pi over 2 minus x? That's a cos x. And that's why that's a tangent x. You can show this relationship by just changing the formulas and keep putting, well, basically it's based on this formula, okay, based on those two, sine pi over 2 minus x and cos pi over 2 minus x. And you can just do some adjustments to it. That's it. Similar, like if you want to prove the rest of it, like it's all the similar things. So sec pi over 2 minus x, you make it 1 over cosine, and you know cosine is equals to cosine pi over 2 minus x is sine x, and 1 over sine x is cosec x. So you just need to prove this relationship. I don't want you to remember it. It's nothing important to remember in this section. Like it's just how you can find the formula by yourself is more important. Okay, so I'm just listing a couple of that here. And the Pythagorean identity, last lesson we have talked about that. Think about the three triangles, top two squared, adding give you the bottom one. This one we use in a lot of situations, but these two, we'll use that in the diff and antidiff section. It's very useful. Okay, in the diff and antidiff section, like when we do differentiation and anti-differentiation for circular functions, that's very important here. So you won't really see a lot of use of that now, but in the later exercise, it's very helpful. So you better remember that. Okay, better remember that. I'll show you examples later. Okay, so I want to evaluate the following. Say I'm not going to evaluate sine, cosec, sec, and cot. So all I'm going to do is I will make it 1 over cosine 13 pi over 4. Okay, so I will just then evaluate the cosine. So 13 pi over 4. If I can subtract 16 pi over 4, that's a minus 3 pi over 4. Okay, so I'm subtracting 16 pi over 4, that's subtracting 4 pi from it. So I get minus 3 pi over 4. So cosine minus 3 pi over 4 is here. So it's in the tangent quadrant. So that is equals to 1 over negative cosine pi over 4. That's 1 over negative 1 over root 2, and that's a negative root 2. I'm not going to show all of it, just like say sec, cosec, and cot, we all evaluate by convert that back into sine, cosine, and tangent, and how you evaluate that is depends on what you learn in method. So finding the reference angle, okay, so negative 3 pi over 4 is here. The reference angle is pi over 4. It's in the tangent quadrant, so that's why it's negative cosine. So it's negative cos pi on 4. Anyone got problems with evaluating circular functions? If not, I'll just move on from this section. It's not that important. Well, it's important, you need to know how to do it, but if we all know how to do it, we can just move on. Anyone got questions? Okay, if not, let's have a look at the next one. Let's do B first. So I want to simplify the following trick as much as possible. What you will do first? Which formula you use first? Difference of perfect square. So I have cosine squared x plus sine squared x. And cosine squared x minus sine squared x. What's the first bracket equals to? 1. And what's the second bracket equals to? Cos 2x. Thank you. Have we learned the double angle formula? But I mean, in the last year, have we talked about it? Yeah. Okay. Good. I think A and B is basically mostly revision from last year thing. So, well, I just put it here and try to test if you remember or not. Yes? Yeah. Yeah. So I'll just briefly talk about double angle formula later, and that's it. All right. For the next one, well, you have two fractions. Obviously, I'm going to make a common denominator first. And then the top is cosine x minus 1, and then minus cos x plus 1 in the bracket, like this. So I'll have cosine x minus 1 minus cosine x minus 1, that's minus 2. And then I have cosine squared x minus 1. What's the bottom becomes? Sine squared or minus sine squared? minus sine squared x, because 1 minus cos x squared give you sine squared x, and if you flip it, it will be negative. You negative both sides, and that's just 2 over sine squared x, and 1 over sine is cosec squared x. Well, this really looks simple in the end. Okay, just playing with the formula a little bit here. Cos minus 1 minus cos minus 1 when you open the bracket. Top line here. Extend cos minus 1 minus cos minus 1. Yep. All right, next one. I hope everyone can just have a look about this one because I want to introduce this method. I think you should learn this already, but like make sure we for the next exercise I can use this method to everyone. Like I hope everyone can just have a look first. So this one is basically drawing triangles in the Cartesian plane. I think most of us are using this method. So just showing, make sure you understand it because I will use this a lot in later on study. So cot is 1 over 10. And that equals to minus 24 over 10. I'll make a fraction. Okay, so just trying to make a fraction. That's minus 12 over 5. Therefore, like I like to convert things back to sine, cosine, and tangent. So tangent equals to minus 5 over 12. Opposite over adjacent. Okay, let's have a look. Which quadrant my angle will be? The first quadrant, right? So 3 pi over 2 to 2 pi. So I will just draw a triangle in the first quadrant. With x is positive but y value is negative, and the hypotenuse is always positive. And this is my x. Again, talk about x here. This is my x. But it's the same as talking about this theta here because it's the reference angle. When you talk about angle x, it's the same as you talk about the theta. It's the same ratio with negative and positive into consideration. So what I have is tangent x equals to negative 5 over 12. So my tangent theta will be negative 5 over 12. So the opposite is negative 5 and adjacent is 12. The negative must go with the 5 because it's going down, like the y value is negative. And you know 12, 5, and 13 is the right angle triangle. So that's the triangle here. After I draw that triangle, I will say cosine x. Well, cosine x equals to adjacent over hypotenuse. So it's 12 over 13. Okay, so positive 12 over 13. And cosec is 1 over sine x. It's 1 over sine x is opposite over hypotenuse is minus 5 over 12. And that is 12. Oh, sorry, 13, not 12, 13. Hypotenuse 13. So minus 5 over 13, and then flip it, minus 13 over 5. And then sec is 1 over cosine, and minus 2 over 3 times cosine is 12 over 13 positive, and 1 over that is 13 on 12. It's positive for this one, so that's 1, that's 6, that's minus 13 over 18. Yeah, so remember how to draw this triangle in the Cartesian plane because we use that a lot later. When we talk about the inverse ones, like it's very important thing here. All right, move on to exercise B. Okay, it's up to here. Well, B is basically talk about the compound angle formulas and double angle formulas. I think it's all on the formula sheet. Sine x plus y, sine x minus y, cos tangent x plus y and x minus y. Well, I don't need to repeat the formula, it's just here. Sine is sine cos plus cos sine, and the minus is the same way, but put the minus. But cosine is the reverse way. If you plus them, you have the minus in between. If you minus them, you have the plus in between. And tangent is the one really hard to remember. Okay, tangent is why quite hard to remember. If you can't remember, it's on the formula sheet. I don't think it's a big problem. You just need to know how to use them. The important one I require you to remember is the double angle formula. Okay, double angle formula basically come from the previous couple of lines. You just need to change all the y's into x, and you see what's happening to the formula, and you will have what's given here. The most important one is the cosine one. Okay, in antiderivative of circular functions, we use the cosine double angle formula a lot. Okay, we use the cosine double angle formula a lot. So that's something you must remember. Okay, must remember, because cosine 2x can become three things. Okay, it can be this, or it can be this. You need to remember all the combination. The most important one is number 2 and number 3. Number 1 is not really with a big use of it. Like 2 and 3 is really the one we use in the future. Sine checks is important as well when we do diff and antidiff. So that's something important. Well, tangent one is kind of not that important. Okay, not that important. I'm not sure. Double angle for the compound one, I'm pretty sure is on it. Like you need to check with the current one. Like I haven't really read the formula sheet properly. But if you know this one, you can work out the double angle one by yourself by changing the y into x. See that sine cos plus cosine, so it's 2 sine x cos x. So we can check later after this. All right, everyone. Thank you. For this one, how I can use a compound angle formula to evaluate this? That's one. Well, I'm not going to complete everything. I think we do this last year. So that's 1 over cosine. And how I can change the angle into one angle. Which angle adding together? Yeah, so 2 power over 12 and 3 power over 12. Okay, so it's a 5 power over 12, and I can use the double angle formula and the compound angle formula above to work on it. I'm not going to finish this one. You can do the rest. What's the tangent? How I can work out the tangent? Think about the method. It's half of pi on 4, right? I can't use double angle formula. It's not like something times by 2. It's half of it. So how about half? How I can do the half one? So give me an equation. What's the relationship between tangent pi on 4 and pi on 8? Pi on 8 what equals to pi on 4? Times 2. That's the double angle formula, right? What's the left hand side equals to? 1. And what's the double angle formula? It's 2 tangent pi on 8 over 1 minus tangent square pi on 8, right? If I can expand the right hand side by using the double angle formula. So I will let, well, if you can't see it, I will let tangent pi on 8 equals A. Just make myself look easier. So that's 2a 1 minus a squared. One minus a squared equals to 2a. A squared plus 2a minus 1 equals to 0. Well, I'm just solving for a. You can just solve it by yourself. But what's important is I will solve out 2a values. So minus b plus minus square root b squared minus 4ac over 2a. That's minus 2 plus minus 2 root 2 over 2. And that's minus 1 plus minus root 2. which one should take? The positive one. What the argument you will make is because tangent pi 8, the angle is in the first quadrant, so this value must be greater than 0, but pi 8 is a positive, like first quadrant value, so tangent pi 8 equals to minus 1 plus root 2. Okay, when you have the angles, you need to do by going set up this kind of equation, like start from the double one. So tangent pi 4 is 2 times of tangent pi 8. And then use the double angle formula on one side, and the other side I can evaluate. Then you have an equation to solve, and we can solve out tangent pi 8. All right, next page. Okay, let's try to do this again. Put root 5. This one is a really good one. Tangent root 5. Tangent x equals to root 5. So I'll put root 5 as root 5 over 1. And pi to 3 pi over 2. Which quadrant is that? Third quadrant. So I just draw angle here. So it's actually this angle, but it's same as consider about this angle here, not x. Let's use that as a theta. Think about this angle theta is the same thing. Okay, what's this length must be? Like this one. Or let's think about opposite one. Opposite, what's opposite must be? Root 5? Negative root 5 because it's going down. How about the adjacent one? Negative 1, correct. What's this one? What's that? Root 6. Root 5 squared is 5, 5 plus 1, 6, root 6. Hypotenuse is always positive, okay? And then the positive and negative of the straight side, you need to think about whether it's the negative side of x-axis or negative side of y-axis. Okay, so this is x, this is the angle x. And then we can do the angle for y as well. Which quadrant is y? Fourth quadrant. So fourth quadrant here, this is the angle y. Well, same as talking about this angle beta here. So cosine y is 105. So what's this one must be? This length, 1. And what's that one? Root 5. And what's that? 2. Minus 2. Negative is going down. Okay, so it's the fourth quadrant. The y value is negative. It's going down. So 4 plus 1 is 5, root 5 here. Okay, so that's the triangle. Now I'm going to talk about sine x. So it's 2 sine x cosine x. Yeah, 2 sine x and cosine x. And what's sine x, everyone? Minus what on what? Yep. What's cosine x? Yep. That's it. So there's 2 root 5 positive 2 root 5 over 6, and there's root 5 over 3. Okay. B. How we can do B? Y over 2. Cos y equals to cos 2 times y over 2. So what's cos y? I think it's positive. Positive. Yes. And which one? Like that, I can do 3 ways, like cosine square minus sine square, 2 cos square minus 1, or 1 minus 2 sine square. Which one will pick? 2 cos squared y over 2 minus 1. I'll definitely use this one because I'm looking for cosine y over 2. I won't put it into the 1 minus 2 sine squares because I'm not even interested in the sine square. So I will let say cosine squared y over 2 becomes a. Cosine equals to a. And then 1 over root 5 equals to 2a squared minus 1. That's really horrible to solve. Well, plus 1. So that's root 5 over 5 plus 1 equals to 2a squared. And then we have root 5 plus 5 over 10 equals to a squared. Yes? 5 over 5 plus root 5 over 5 times by a half, that's over 10. And a is plus minus of square root 5 plus root 5 over 10. Positive or negative? What's the angle for y? Y is 3 pi over 2. So y over 2 is in between that, right? Divide 2 on everything. Y domain is that, right? That's the domain of y. Now I'm talking about the angle for y over 2. So you need to halve the angles. So which quadrant is that? Second. So it's positive. Cosine, sorry, negative. That's the sine quadrant. So cosine of that will be negative, less than 0. Make sense? I divide 2 on everything. Inequality, you need to times or divide same thing. So I divide that by 2. This is to be divided by 2, and that is to be divided by 2. So times a half on everything. So cosine y over 2 equals to negative root 5 plus root 5 over 10. Well, it's not nice, but that's what you can get. You take the negative. Okay, you take the negative. You need to know how to find domain. You have a lot of questions asking about how to find domain. So you have the original one, and you think about what you have done to your angle. You halved your angle, so your domain needs to be halved as well. If you double your angle, say 2y, so you double your domain as well. So that's how you do it. Okay, set x of x minus y. What's cosine? Cosine x minus y, what's the formula? Cos. I think it's cos plus sine. Yes. Okay. Everyone, I'm not going to do the test. I'm not going to do the exam. You need to remember this, okay? So trying to find a way. It's not that hard to remember. So cos is the cos plus sine. Believe me, you don't have time. When you're in that nervous situation, you don't have time to always go back to your formula sheet. Even though it's just there, you're not going to use it very efficiently. So that's why I never look at it. I think it's kind of useless because I'm so stressful all the time. I'm not even know what I want to look at, and I don't know where I want to look at. So it's just like the time limit. It's just about pressure and the time. So trying to remember as much as you can is better. Okay. You stop Cincy and you do the calculation. I don't want to continue. I don't want to do the calculation. What's the tangent x plus 2y? Just do the compound angle formula first. So what's the top? Yep. 1 minus 10x and 10 to y. What's 10 to y equals to? Yep. Good. You remember. And you just put values here and trying to find out what is it. Okay, so what's tangent y? Go back to the, what's tangent y? What's tangent y, everyone? Tangent y, -2. Tangent y is -2. What's tangent x? √5. √5, yeah. Okay, and then you put values in and you can work out the value, but I'm not really interested in doing that. Just be careful with the negative and positive. Okay, the negative and positive, read the graph clearly and carefully. For the next two is like proving show that questions. You can just play with it and try to use the formulas. Some student asked me, is that just like when you're lucky, you just get it right and you get it, and when you're not lucky and you just don't get it? I said, well, there are some tips for it. You just need to pick something that looks like it and then to start with. Well, correct. If you start with the wrong thing, you're completely wrong and you're not going to get the final answer. So just you need to keep trying. Okay, just need to keep trying. If it's not lucky enough for the first time, try something else in the second time. I'll just stop here for next lesson will be working lesson. So I finish exercise A and exercise B. So tomorrow I'll do C. Okay, tomorrow I'll do C.